Today I'm going to discuss about the topic. Topic is your Wien's displacement law, Wien's displacement law, Stefan's law, and Newton's law of pulling. So Wien's displacement law states that the wavelength of the maximum intensity of the emission lambda m of the black body of radiation is inversely proportional to the absolute temperature of the black body. Let us consider this is a black body, and as soon as the gets incident, so after incident black body will absorb the light or absorb the heat, not only light as well as heat. So when it absorb, after absorption it will start radiating, heat. So as soon as it will start radiating heat, so it has some wavelength, and this wavelength is called lambda m. This wavelength is called lambda m. So the wavelength is inversely proportional to the temperature. If temperature is very high, so lambda wavelength will be less. If temperature is very low, so lambda will be very high. So from the graph, we can understand how this situation has been changed. So let us see the graph. Graph, the y-axis shows the wavelength, and the x-axis shows the spectral radiance. So the comparison of the graph of the spectral radiance as well as wavelength. So when we see that the temperature first temperature is 3500, first temperature is 3500. So when temperature is when temperature is 3500, when temperature is 3500, so the wavelength wavelength is here. Now as soon as temperature increase from 3500 to 4000, so the wavelength become less. Again, when the wavelength temperature become 4500, so the maximum wavelength of this is this one. As soon as temperature has increased to 5000, so its wavelength came here. As soon as it has increased from 5000 to 5500, so the final wavelength is this. What does it means? As temperature is increasing, the maximum wavelength is decreasing. So the maximum wavelength of the radiation wave is directly inversely proportional to the temperature. So that's why Wien's displacement. This law is known as Wien's displacement law. That always there is a shift of a lambda, or always there is displacement in the opposite direction. That is, there is a decrement of the displacement as soon as the temperature is increasing. Now I am talking about Stefan's law. What is Stefan's law? The amount of heat energy radiated per second per unit area of a perfect black body is directly proportional to the fourth power of the absolute temperature. So let us consider this is a black body, and it is your perfect black body. So whenever light will get incident on this, so mostly 99.99% light will get absorbed, and the amount of heat energy radiate per second. So as soon as it will light or heat energy will radiate, after that it will radiate it. Whenever any heat or light will incident on any black body, so after absorption of the heat energy, so the radiation will start coming out, and the radiation per second per unit area, that is E, is directly proportional to the fourth power of the temperature of the black body. If temperature of the black body is very high, so it means that energy will be also very high. But E is directly proportional to the fourth power of the temperature. So if temperature has been increased 2 times, then energy will increase 16 times. And when we remove this proportionality constant, so finally we will get the proportionality constant as Stefan's constant. And this Stefan constant is known as 5.67 into 10 power minus 8 watt per meter square k to the power 4. So I hope you have understood this. Now let us discuss about the Newton's law of cooling. What actually Newton's law of cooling shows? Newton's law of cooling. Before understanding, we need to understand the statement. According to this law, rate of loss of heat means how much fast, how much rapidly any object is cooling. So rate of heat loss, that is dq by dt, is directly proportional to the difference of the body in the surrounding. Let us consider. Let us consider there is a body. It has having a temperature of a T, and its surrounding has a temperature of T naught, that is ambient temperature. So let us body has a temperature of 200 degrees Celsius and surrounding has a 30 degrees Celsius. At the same time, there is another body and it has a temperature of 100 degrees Celsius, but its surrounding is 30 degrees Celsius. Now, the rate of cooling of the high temperature difference, see here, the temperature difference is 170 degrees Celsius, but at this, the temperature difference is only 70 degrees Celsius. So the rate of cooling of this body is high. Rate of cooling of this body is high as compared to this because it has very high temperature difference. So it means that as soon as the temperature difference is more, the rate of cooling will be more. So it means that dq by dt, that is rate of heat transfer, is directly proportional to T minus T naught, and where T naught is the ambient temperature, T naught is the ambient temperature, T is the temperature of the body, T is the temperature of the body, and finally I have written here minus dq by dt into K into delta T. Why I am telling here minus sign indicate K is a positive constant, depends upon the nature and the area of the body, but negative sign shows that dq by dt is decreasing. Dq by dt is decreasing because it is a cooling process. So rate of heat transfer will decrease after some time because as soon as it will start cooling, so the temperature of body is also getting cooled. So that's why it is known as Newton's law of cooling. So I hope you have understood why there is a negative sign. Why there is a negative sign. Why there is a negative sign minus dq by dt. Why there is a negative, it is coming out. Now, as dq is equal to m's as dt. As dq is equal to ms dt, as we have studied in a temperature. So the rate of heat loss, that is divide, if you all equation will be divided by dq by dt, then m as dt by temperature difference by time. Now dq by dt is equal to what? Just now we have discussed that dq by dt is equal to minus k delta t. So here we can write ms dt. Here we can write ms dt by minus dt by dt in a negative sign, and this is equal to k into temperature of the body minus temperature of the ambient temperature. Now just rearrange the equation so that we can get this equation dt by t minus delta t is equal to minus k by ms into dt, that is the time. Now minus k by ms can be written as capital K, and this is considered as a constant. So minus k dt. So dt by t minus t naught is equal to minus k Tt. It is a time and it is a temperature. So I hope you have understood this one. Now as we have got this equation, dt divided by t minus t naught is equal to minus ktt. Now here dt is a small time period and d capital T is the small temperature difference. Temperature. Capital T denotes the temperature. Now if we integrate both the sides, so our temperature starts from initial temperature Ti to T final temperature, and is equal to minus time start from 0 to T. So finally we are getting minus kT, and this is equal to log T minus T naught. So finally log T minus T naught is equal to minus kT plus C. C is also a constant, or C is a constant. So from here what we can do, from here log, if we remove the log, so what will happen, T, that is temperature at any instant, is equal to ambient temperature plus C dash into e to the power minus k T, where k is equal to small k by ms. So what does small k is there? K by ms. K is a constant, okay? K is a constant of proportionality. So I hope you have understood this equation. By using this equation, we can solve the problem. Thank you.